Hello everyone and welcome to another Rich Code USACO Bronze video. In this video, we will be going over problem 2, Circular Barn, from the 2015 to 2016 season's third contest, which was in February. So, problem is this. So, being a fan of contemporary architecture, Farmer John has built a new barn in the shape of a perfect circle. Inside, the barn consists of a ring of n rooms, numbered clockwise from 1 to n, around the perimeter of the barn. So, that just means if he has, let's say it's like it's kind of like a circle where this is one, two, three, four, and it continues going on to n, and then n goes back to one. And then so each room has doors to its neighboring rooms and also a door opening to the exterior of the barn. And Farmer John wants exactly Ri cows to end up in each room I. And to herd the cows into the barn in an orderly fashion, he plans to unlock the exterior door of a single room, allowing the cows to enter through that door. Each cow then walks clockwise through the rooms until she reaches a suitable destination. Farmer John wants to unlock the exterior door that will cause his cows to collectively walk a minimum total amount of distance. Please determine the minimum total distance his cows will need to walk if he chooses the best door to unlock. The distance walked by a single cow is the number of interior doors she passes. So if let's say there's a two, so if you went from one to four, the distance would be three, as there's one, two, three doors. And, and so the first line contains n, and each remaining n lines contains ri, r1 to rn. So in the sample test case, there is 4, 7, 8, 6, 4. And the optimal way is to let cows in through here. Okay, so the way you could do this is you can just check for each room how much if I open that if that door is the one opened, what will the distance the cows travel will be? And then we find the minimum and that we will output that. So first line contains n. Okay, so now we have taken an input. We can now just determine for each room, if that is the only one opened, how far the cows will walk. So we can do that. And then, so we currently have max is currently the integer.max value. So but by doing that, we can guarantee that max on the first run will always be greater than whatever, even if each cow has to walk very, very, very far, it will still be less than max. And then, so to find how far you need to walk, the cows need to walk, we can create a method called check. And in that method, we will take in a number, which is the room that door we will open, and num of, the which is just our array of how many cows go in each room. Now, so there are two ways to simulate a circular room. One way is to keep doing modulus. So if we be on the n minus one room, and then we do n plus plus, we will go to n, and modulus n, we return to zero, and we will go back all the way to the front. The other way to do this, since at most a cow will walk n minus one rooms, a cow will walk and eventually will end up here, and will not have to walk back over to that room again. So then instead we can simulate it as having just two arrays where each array is the same. And if a cow traveling in a circle, normally instead of going back here, we can go just keep going forward. And since these two arrays are going to be the exact same, it will still be the same thing as a circle. So in order to do that, we will make num of 2 times n, and we will make num of I plus n same as num I. And now we'll write our check method. So then we can do set a total distance to 0, and we go through for equals start I is start plus n. Since you will travel at most n rooms, so you can go to less than start plus n and I plus plus. So the distance traveled is the number of rooms traveled multiplied by the number of cows needed in the room. So then we can do I minus start. That will give us the number of doors they have traveled, which is the distance traveled, and you just multiply it by num of I, which is the number of cows traveled. And at the end, we just return the total distance. And then we can just output maximum, the maximum, and we can close our output, and we can try submit it. Okay, so on 9:30, we have received the integer index out of bounds error. Okay, so that just means that when we set num of I is equal to 2 times I, which makes sense since this should be divided by 2 since num of is 2 times n. And once we fix that, let us try again. And as you see, it works. So thank you for sharing. Thank you for watching.